Welcome to qnawire.
The given question can be understood by this diagram. In the question it is mentioned that two blocks A and B, the mass of block A is given as MA and the mass of block B is given as MB. They are in contact. Now an experimenter is pushing the block A from its behind by applying a force. Okay, let's say that force applied is Fe. Now due to that, block A is exerting a force on block B whose value is given as F. So we have to find the value of this Fe force, the force exerted by the experimenter on block A. So Fe is the force exerted by experimenter on A, and over here you see F is the force on A by B, and this force, remember, this is the contact force between A and B. So then I can conclude that if A is applying an F force on B, then similarly B is also going to exert an equal and opposite force on A, that is going to be F backward. Now as both A and B blocks are in contact, so if this A block is moving forward with an acceleration of A, then B also will be moving with the same acceleration A. So A represents the acceleration of both the blocks forward. Now let's try to see what are the forces acting on the each of the block. Okay, now on A block, mg force is acting downward due to gravity. A normal reaction force will be acting upward due to the contact surface, due to the lower surface. Let's say that is Na, and F force is acting backward and Fe force is acting forward. Okay, now on B block, Mb G force is acting downward. Okay, sorry, I made a mistake. On A, the force due to gravity will be Ma into G, as its mass is Ma. Okay, now on block B, what is the normal reaction force? That is, let's say, Nb. And then on block B, another force is F force, which is the contact force by A on B. So if I draw now the FBD of block A, the free body diagram of A, I will get, here is my block A, MAG force is acting downward, NA force is acting upward, F force is acting backward, and Fe force is acting forward. And because of that, this Ma mass is moving forward with an acceleration of A. So I can write then by applying Newton's second law along horizontal direction, the net force, which is going to be Fe minus F, is equal to Ma times A. This is, let's say, equation number 1. Now if we want to draw FBD of block B, FBD of B, then we have to replace the block B by a dot. Downward force on the block B is Mbg. A normal reaction force will be acting upward, that is Nb. And then as you can see, one more force F will be acting forward. So F force is acting forward, and because of that this block whose mass is mb is moving forward with an acceleration of a. So then again applying Newton's second law along horizontal direction, we can write the net force, which is nothing but only F, that is going to be equal to mb into a. So this is my second equation. Now from 1 and 2 I can write, from equation 1 and 2 I can write. So from equation 1 I can write that Fe minus F, in place of F what I will write, I will write mb into a, mb into a, that is equal to ma into a, ma into a. So on simplifying this I will get a equals Fe by ma plus mb. Okay, then let's say this is my equation number 3. So from 2 and 3 I can write, from 2 and 3 I will get F equals mb into, in place of a I will write Fe by ma plus mb. So from here I can write Fe, which is the value of the force exerted by experimenter on A, that is going to be equal to ma plus mb by mb multiplied by F. Again on simplifying this we can write Fe is going to be equal to 1 plus ma by mb into F. So this is the answer for the question. Thank you.